Good afternoon. This is the start of what I did for the 6-1 ambiguous case notes. So make sure you watch this first and foremost. This was just a bunch of information I had my students write down at the beginning just because it's stuff that we need to go over. So I'm going to talk through this pretty quickly, but you may want to stop this kind of often and copy down stuff as I go. So the ambiguous case is ASS, angle, side, side, and when it has that orientation, you have an angle and then the next two sides if you just essentially like go around in a circle from there. One important distinction is the SAS case. This is different. SAS is when you have an angle sandwiched between two sides. So that's different from what we have here because we don't have this side that touches the angle. We just have the next two after that angle, if that makes sense. But what I basically said is if you get these mixed up, it's not a huge deal because they're solved completely different ways. So if you try to solve ASS like an SAS, you would hit a dead end pretty quickly. So that is kind of the saving grace here if you do get these two mixed up. With that being said, the ASS case is quite complicated because of how we have to solve it. So we solve it using the law of sines, which we did in the previous notes with the angle side, the AAS and ASA problems. But then also we have to use inverse sine, and inverse sine is what complicates this process. So we use both of these to solve, and because of the inverse sine, that creates a problem. First, why it creates a problem. It comes from the fact that the range, the outputs of inverse sine is from -90 to 90. So the largest number I can ever get from this function is 90 degrees. Now, if you think about angles, we have angles larger than 90 degrees that we can have. And so it cuts out any of those possible answers. That's the issue. So this kind of expands upon that. When we use inverse sine to solve for missing angles, it will never give us an obtuse angle more than 90 degrees. So we have to solve with inverse sine, and it will not give us anything over 90. So if the angle we're solving for is supposed to be obtuse, we won't know it because we're not going to get that kind of answer. That's an issue. In the problem above, the picture I drew, angle C, and I'll flash back up to that, this angle right here could be obtuse. This is what we would solve for right out of the gate. It could be obtuse, but we will only get an acute or right angle as our answer since we must use inverse sine of x. So if we solve this problem, we would have to use inverse sine of x, and it would either give us an angle less than 90 in acute, or it would give us 90, which is right. But if angle C is supposed to be obtuse, it's not going to give us an obtuse number, which is an issue. So the big kind of thing you need to be aware of after all of that, if your triangle is angle side side, if it has that orientation, then you will need to make two triangles as there may be two possible answers. So anytime you identify that this is what you have as your case, you need to set up two triangles as part of the solving process. Now, that doesn't mean that you will have two triangles as your answer. Sometimes you will have two as your answer. Sometimes you'll only have one, and if you're really lucky, you will have no triangles. Those problems simplify very quickly because you end up with a no solution type of situation. So it's something you have to be aware of. If you only give one of the two triangles, you're missing a whole half of your answer, an entire triangle as an answer, and that's a pretty big deal. So I know that's a lot all at once. Feel free to go back and pause and maybe re-listen to this after you've written everything out. It'd probably be a bit more helpful that way. And then feel free to go watch the next notes video.